is the DSC computer, and the bottom computer is a TGA computer. How do you know which one you're operating? It's by this little switch over here. If the green light says DSC, that's the one that you're operating. If it says TGA, that's the computer that you're looking at. In order to switch back and forth from each one, you hit the scroll lock button twice, and you will see the screen go black and then turn into what is now the TGA computer, and you will also see the green light would switch out as well. Just hit it again, and now the green light switches back, and you're back onto the DSC computer. Make sure that you're on the right computer before you sign in, so that you're not setting up experiments on the wrong instrument. Also, the instruments operate the exact same software, so make sure that you know which one you're on before you actually go into the software. Alright, so this software is both instrument control and analysis. It's also free to download on the TA Instruments website. If you're going to be using these instruments a lot in the future, it's probably a good idea to just download the software onto your laptop so that you can analyze the software, analyze your data on your own time, that you don't have to actually be here to do any analysis. Once the software is open, there are sort of three main areas: the left-hand side, the middle, and then on the right. The right-hand side is basically going to have all of the real-time information that's coming from the instrument. So all of these numbers that you see down here, many of them will not make sense to a lot of people, but you know, for the advanced user, they would understand sort of what's going on over here. Typically, if something needs to be troubleshooted or something like that, I would look on this right-hand side to see if there's any numbers that are acting funny, things like that. But generally, there's not much to do on this right-hand side. By the way, within that furnace, we are flowing nitrogen by default. Nitrogen is typically inert, so in DSC especially, you generally want an inert gas flowing so that it doesn't affect any transitions that are happening in your sample, and it doesn't encourage degradation of your sample as well. So you generally are running an inert gas, whether that be nitrogen, argon, depending on which instrument you use. But this one, we run nitrogen. Okay. On the left-hand side, this is the experiment tab. We have two sections: the running queue and the design view. Basically, the running queue and the design view are identical in terms of what you do with them, with one major exception. The running queue is directly connected to the instrument. So if you prepare anything on the running queue, the instrument automatically knows that it has some job to do, and it will be sort of prepping itself to do that. The design view, however, is not connected to the instrument. But you can still set up your experiment and everything else in the design view. In fact, I encourage people to use the design view so that in case you come in here and somebody has a bunch of experiments lined up and you just want to fit yours in after, you don't accidentally change something of someone else's or of your own experiment to cause any confusions later on. So to basically start preparing your experiment, you're going to go into the design view and you're going to click Create New Experiment. Once you click on that, you will see that this default holder here says Run 1 Pan 1 Custom, and then the middle section actually lights up. It's no longer grayed out. So now you can go in and start preparing the experiment that you want to run. So in this middle section here, you have these two pieces. The first top piece is your sample information. So you'll be typing in your sample name. So I'm just going to type in test right here. Then you're going to have your pan number. So that's basically the location of your sample on the auto sampler. So if you put a pan in number 35, then you should type in 35 and the pan number. Okay. Then you have two numbers to the right of that on that same line that says size and pan mass. These are two numbers that you will be recording once you actually physically prepare the sample in the pan. The pan mass is actually the empty pan. So it's your pan and your lid without your sample in it. Okay. So you'll be measuring that number and recording it in milligrams. and placing that number in this box. Then the other number that says size, that is actually the size or the mass of your sample, without the pan, without the lid, okay? And that's also in milligrams. So these two numbers should look vastly different from each other. And you'll see an example later on. The reference line down here, the reference positions that I mentioned before, like I said, they are empty. The pans are typically empty, so they're reusable. And so what happens is that you can actually record and save the pan masses in this little drop-down box here. So, for example, if I was using a standard pan, I would choose reference 1, and the pan mass is already saved. Okay, so I don't have to make a new reference for every sample or for every time I come here. The references are there. You can just reuse them over and over. And you select the correct one based on the experiments and the sample that you're trying to do. So if I'm using a standard pan, I will select reference 1. If I'm using a hermetic pan, I'll select reference 2. And again, the number automatically updates in this box, so I don't have to type any of that part in.
So the difference between the number 3, 4, 5?
Currently, 3, 4, and 5 are empty. They don't have anything in there, so these numbers are all old numbers. If you were to prepare a brand new reference pan, or you want to prepare a reference pan, you can place it in 3, 4, or 5, and you would have to come in here and hit the edit button. So for example, I want number 3, I would hit edit, and then I would go in and change the numbers that are associated here. The size means the same thing. Again, typically that size is 0 if it's an empty pan. If it's not empty, like these two were, for some specific experiments that we were running, you would have to put in the sample mass in here, and then the empty pan mass goes on the left-hand side. Okay. Like I said, typically, 99% of the people walking in here won't need to prepare a new pan for themselves. If you would like to, sure, go ahead. But you can easily reuse a reference 1 or reference 2 to run any experiment that you want. Okay. The other lines down here are operator, so you can type your name as the operator. If you have a specific project that these are associated with, or any other notes that you have, feel free to use or not use any of these 3 lines. The final piece is down here in the file name. You click this arrow, you would see that it goes to a default folder that says data. Within this folder, however, there are other folders for individual users. So when you come in, especially if you're coming in to use it for the first time, you would need to make your own folder within this data folder. Okay. Now, how do you do that? You go to this button right here with the ellipses. You click on that, and a mini browser will show up. And basically, you want to follow this line until you get to the data folder in this mini browser. So you're going to go to the C drive, so computer, C drive, then program data, which is down here, program data, then TA instruments, and trios, down here. And then that's the data file is right here. Once you click on that, you will see a bunch of people's names. So in this folder is where you will hit make a new folder, and you will create a new folder with your name on it, and make sure to save all of your data directly to your folder. This way it avoids any confusions of anybody else's sample being confused with yours, or somebody has the same sample name, etc., etc. Saving it directly to your own folder eliminates all of that. Okay, so make sure that you either find your own folder or make one for yourself. For this example, I'm just going to go to my folder. It's right here. And once you highlight your folder, you hit OK. And you would see that the extension is changed to point directly to my folder. Okay, so that's what you want to do before you do anything else. By default, the sample name up here, so whatever you type in here, becomes the file name for your data file. Okay, so I type test in here, so now my file name is test. Okay, I know people have filing name conventions. They like to put in their date, their name, and all these other things. Feel free to do that. There is a somewhat easier way for more sort of basic filing conventions, and that is this template line down here. When you hit the add token, you will see that things like operator, project, sample name, these are these same things that were up here. Okay, so these are not just things that you type in, but they're also placeholders. So whatever you type in there gets saved in a sort of a temporary file. And what you can do is that you can build your file name using these things. So for example, if I like to put my filing convention as the date of my run, so it'll be today's date, I can click run date, hit insert. It accepts other characters and things in this line as well. So let's say I put a dash, and I hit add token again, and I want to put my name. I already typed my name in the operator, so I can click operator, insert, add another dash, and then I want to put in the sample name, so I click sample name and hit insert. So now what you will see, hi Jing. Now what you would see is that the sample or the file name now has today's date, 9/17/2018, dash my name dash test. Okay, so these templates are basically placeholders for whatever you type in here, and you can basically build your file name around those placeholders. Okay, and of course, once you're finished with that, you can sort of just close that up just to make it look neat. But this is basically where your file is going to be saved under your name, and then of course the file name or the data file name is whatever you set it up to be. Of course, you can type these same things directly into the sample name. It's just a matter of preference. For me, this is just easier. I just click a few things and the name is set. But you can feel free to type, basically whatever you want in the sample name. So once you're finished with this top section, now you're going to go down to the procedure. Of course, the procedure is exactly what you want the instrument to do to your sample in terms of testing it, right? So we have a few more drop-down boxes here. The mode, again, it should be on standard. If you hit the drop-down box, there's two other modes. Of course, one says calibration. Of course, the calibration is done by people at AMCL, so please don't mess with anything that says calibration. There is something called modulated DSC or temperature modulated DSC. It's a very specific type of experiment. I won't be going into it on this training, but it can come in handy for some more complicated types of experiments that may need some transitions to be separated from each other or things like that. Modulated mode would at some point help in doing that.